Now we've discussed in the previous part that the mean is not a resistant measure and the median is a resistant measure. Because the mean gets pulled in the direction of the skew, it gets larger for a right skew, larger than the median for a right skew. It gets smaller than the median in the case of a left skewed distribution. Now let's look at example 5. Even if we didn't have technology to graph this, it's pretty clear that it's a perfectly symmetrical distribution. And if you calculate the mean and the median for a perfectly symmetrical distribution, the mean equals the median. Now let's look at 6, and it's pretty clear that this has a right skew because of the high outlier here. We can describe this as a distribution that's skewed to the right. And even before we calculate the mean and the median, is it quite clear now that we've discussed how the mean gets affected by the outlier, that the mean, which is x bar, would be greater than the median, m. So let's see what the calculations show. So just as we guessed, the mean is greater than the median. The mean is 4.5, whereas the median is 3. So for a perfectly symmetrical distribution, the mean is equal to the median. If the distribution has a skew to the right, then the mean gets pulled to the right, which means the median gets smaller than the mean, or the mean is larger than the median. So in general, you need to remember this. Symmetric distribution, mean is equal to the median. We're talking about a perfectly symmetrical distribution. If it's roughly symmetrical, then the mean will roughly be equal to the median. For a distribution that is right skewed, the mean gets pulled in the direction of the skew, so it becomes greater than the median. For a distribution that is left skewed, the mean gets pulled to the left, which means it gets smaller than the median. Both the mean and median are measures of the center, but in the case of a skew, the median is a better representative of the center. Again, let's quickly review important facts about the mean and the median and how they compare in the case of symmetrical distributions and distributions that are skewed to the left or right. So the median and the mean both measure the center. The median is resistant because it doesn't get affected much by the outliers. The mean, however, is not resistant because it gets pulled in the direction of the skew. For example, if we have a set of numbers and all we know about the set is that the mean x bar is equal to 34 and the median is equal to 55, clearly the mean is less than the median. So what can we say about this distribution? We know that the mean gets pulled in the direction of the skew, so we can conclude that there is a left skew in this distribution, or the distribution is skewed to the left. Now suppose we have a set of numbers and all we know about the set is that the mean is x bar 10.5 and the median is m, which is 4.2. Clearly here x bar is greater than m, which means that the distribution has a skew to the right, which means it has a right tail, because the mean always gets pulled in the direction of the skew. The mean gets larger than the median, which remains somewhere in the center. What if we know that the mean and the median are exactly the same? Then how do we describe the shape of the distribution? This can happen only if there is perfect symmetry. If the distribution is perfectly symmetrical, that's when you know for sure that the mean would be exactly the same as the median. Do the mean and median have units? Yes, we've discussed this several times. Both the mean and the median have units depending on the units of the entries in the data set.